Welcome everyone to our lesson on derivatives of trig functions. Right, so in this lesson we'll be talking about the derivative of sine x, and the derivative of cos x, and derivative of tan x, and we will solve more questions and then see how they all work out. So let's get started. Right, so let's work with the derivative of sine x. Now, when you differentiate sine, you get cos, okay? So when you differentiate sine, you get cos. How about when you differentiate cos? Okay, so when you differentiate cos, you get negative sine, all right? When you differentiate cos, you get negative sine. So think of only one, okay, so that it would stay in mind. Think of only one. Think of when you differentiate sine, you get cos. End it, so that you know that if we are going from cos to sine, is the opposite direction, hence you get a negative. Okay, like let me say it once more. Keep only one rule in mind, that okay, when I differentiate sine, I get cos. Okay, then you think of it this way: when you are moving from cosine to sine, that is opposite, so you negate it. This way it will stay. Right, how about tan? So the tan, the proof is a bit complicated, you might say, but let's go through so that we will know how the tan derivative was derived. Okay, so let's do it. You know that tan is the same as sine over cos from our study of trig. All right, now a function is dividing another function, so that is a quotient. So if it is a quotient, how do we treat it? So when we are to differentiate tangent, that would mean that we would keep the cosine, okay? Then we would differentiate the sine minus. Now we keep sine and then we differentiate cos, okay? All over cosine squared. All right, so this is what we call the quotient rule, and that is what we have applied on this. So now let's actually differentiate sine x and then cos x and simplify to see what we will get. Right, so I've repeated it for us here, so let's clean it up. Now when you differentiate sine, we said you get cos, and when you differentiate cos, you get what? Negative sine. Okay, remember you have negative sine times negative sine, so that has to be positive. Okay, so now let's clean it up. Right, so cosine times cosine will give you cosine all squared. Okay, cosine all squared is also written as this, that cos square x. All right, so when you see cos square x is the same as cos x all squared. I mean, like in a bracket, all squared is the same. Now you have sine times sine, that is sine square x, and then this is negative times negative, so that will give us positive. But from our study of trig, we know that there's an identity that says cosine square x plus sine square s should give us 1. Okay, so this has nothing to do with differentiation. This identity is purely from trigonometric functions. So we would substitute that. So instead of rewriting cos square x plus sine square s, we just write 1, okay, because we know that that identity exists. Okay, so we have 1 over cos square x. Then from trig, we also know that 1 over cosine is sec, okay, 1 over cosine is sec. So if this is squared, then it means that you have all this squared, all right, all this squared, because 1 squared is still 1. That would mean that 1 over cos square s will become sec squared, okay, right? So that would mean that we have sec squared. So the differential of tan gives sec squared, okay? So that is the new law. We have come to see that when you differentiate sine, you get cos, and when you differentiate cos, you get negative sine. When you differentiate tan, you get sec squared. Okay, so now let's practice with some examples. We have y equals 3 sine x. Now to differentiate this, we will keep the 3, okay? Then we differentiate sine. Now when we differentiate sine, we will get cos. Hence our answer should be 3 cos x. Okay, simple. Another one. This is product, okay? Product rule. We have a function called x squared being multiplied by another function called cos x. So we will keep this and we differentiate that plus. Now we will keep this and keep the cosine and then now differentiate the x squared. So let's do that. So we will keep this and we differentiate cosine. That will give us negative sine. Then we will now keep cosine and differentiate x squared, and that will give us 2x. Then we will clean it up. Okay, so this time that will give you negative x squared sine x, then you will get 2x cos x. Of course, you might want to write this first before you bring this. That's also fine. Another example. Now this is quotient. Tan is being divided by another function. Okay, so that's quotient. So we are going to treat it as quotient. Right. So we will keep the x squared. Now differentiate 4 tan x. So you keep the 4 and you differentiate tan x, and tan x will give you sec squared x. Now we subtract, then we keep 4 tan x, and then we differentiate the denominator. Okay, differentiate that, and that is 2x, all divided by the denominator squared. But remember, it is squared already, so that will be raised to the power 4. Okay, then we clean the numerator. So when we clean it up, this will give us 4 times x squared will give us 4x squared sec squared x. Then there's 2x here, there's a 4 here. When they multiply, they'll give us 8. But remember that the negative sign is there, okay? And that is it. But see something, you have x here, you have x there, you have x here. So you can factor x out and then you cancel out. So that will give you this. So when you differentiate this curve, this is the gradient function you would get.